So a particle is moving along the x-axis. They give us the velocity right here. At time equals 0, the particle is at position x equal 1. When I read that statement, I would probably write on my paper the position of the particle at time equals 0 is 1. Find the acceleration of the particle at time equal 2. So I'm looking for the acceleration at time equal 2. I remember from Danica's chart that if I have the velocity and I'm trying to find the acceleration, I need to use a derivative. So a of 2 is the same thing as d of the velocity over, down here we need d of the input variable. In this problem the input variable is t, and we need to find this derivative at time equal, as stated here, time equal 2. Because we can use a calculator, I went to my calculator, typed into y1 the formula for velocity, then I used math 8 to find the derivative of my velocity at time equal 2, 1.588. So this is find the acceleration of the particle at time equal 2, period. It's really important that when you're doing an FRQ to again read slow and careful and stop as soon as they ask you to do something. Notice I didn't keep reading, I simply did what they asked. So I found that, and when I'm scoring my work, I noticed that right here is the scoring guide. 2 points overall for this problem, 1 point for correctly finding the correct value of the acceleration. So as long as you have on your paper, you have to show that you are finding the derivative of the velocity. So you have to have this, you have to show that it equals 1.588. If you don't say a of, and you really should say a of 2 as well. So I'm looking for this, because proper notation is going to get you points on the FRQ section. So I'm looking for this. That's 1 point. That's the red point. So 1 point for that. Just going to make a note here. Then I keep reading. Is the speed of the particle increasing at time equal 2? And I remember on the back side of the golden notes, there's this statement about how if we compare the acceleration and the velocity, we can determine whether the particle's speed is increasing or decreasing. So I need to find the velocity at time equal 2 also. So I'm going to find, change color, the velocity at time equal 2. I can do that on my calculator by simply typing y1 of 2. And I get the value. You don't want to write y1 of 2 on your paper. They consider that illegal to use a calculator symbol. But now I have found the velocity. The question is the speed increasing at time equal 2? So I compare the acceleration at time 2 and the velocity at time 2, and then I have to explain to the grader. So this is sufficient. All I would need now is a statement, something like what you see here. So we'll move this out of the way a little bit. So I just need a statement something like this. Basically this will do. Since a of 2 and v of 2 have opposite signs, the speed is decreasing at time equal 2. And that would get me the second point. So the total on this problem is 2 points.